All right. So I'm really not sure why I was just hesitant on deriving the equation here. So we're going to derive an expression for the work done on this gas cylinder. All right, so a couple important things gathered from this kind of image here. All right, so we've got some gas that's at some pressure, and we're going to assume that this piston moves slowly enough where that pressure remains constant. So the pressure in the gas remains constant. The area of this piston has some area A. The volume of gas is V, and let's say it moves some change in height, so we'll use delta Y here. So this piston displaces. So if we're computing, let's say, the work, we know work has the expression of FD cosine theta, all right? And looking at cosine theta, so let's assume this piston compresses downward. So we have the force of the piston, which is downward, and it displaces downward. So our cosine theta is cosine 0, which is just 1. So we just have force times displacement. The force we're dealing with here is the force due to the piston, which we can relate with pressure and area. So we have work is force, which is pressure times area, times the displacement. What's convenient about this notation then is since these are all multiplied, well, I just move over my parentheses just to kind of see things a little easier. But now we have pressure times the quantity of area times displacement. Now, if you look here, again, my displacement here is delta Y. And that amount there, that area times distance, what's the volume quantity? That's how much our gas changes in volume. So we found here an expression for the work done on a excuse me, on a system here, and we found that the work is equal to the pressure times change in volume. Right, so note that in this situation, we looked at the gas compressing, and we already talked about when a gas compresses, that's adding energy to the system. Right, so this is positive work. Now, if the gas expands instead, we have negative work because the displacement and the direction of the force are in the opposite directions now. So we have cosine of 180 degrees, which is -1. So that's where that negative sign comes from. Now on your formula sheet, this being the Physics 2 formula sheet, I need to change my dimensions. 1 second. I should be able to see the whole screen here. So when we're defining work in thermodynamics, we're going to look at the work done on a system at constant pressure. Now this is called, when we have a system changing and it's constant and the gas remains at a constant pressure, we call this isobaric. We'll get more into the semantics of that later. But anyway, I just put that in there for posterity's sake. So the work done on our system, so on our gas, is equal to -P delta V. All right, so delta V is a change in volume, and pressure is going to be the same throughout its expansion. At least we're assuming that. So this expression is only valid when that's the case, hence the constant pressure. Now we have a negative sign because we state that when work is done by a gas, this is a negative quantity because it's a negative pressure. So kind of note here, all right, with our change in volume, if we have compression occurring or gas gets compressed, then our change in volume is negative, which cancels out this negative sign, giving us a positive work done on our gas, meaning energy is added to the gas, like we said. If we have expansion, our change in volume is now a positive quantity, meaning that the work done on the gas is negative, which means we're taking energy away from the gas. All right, so is the work positive or negative? So the way I like to think about it is whether we have expansion or compression going on and whether we're saying to or by. I say don't memorize this, just think about what direction the force that's doing the work on the gas is acting compared to the displacement, and then kind of look at the ramifications of that. So kind of in summary, what we have kind of in a nutshell is we've got our law of thermodynamics that says that the change in internal energy of a gas is going to be the heat added to the gas and the work done on the gas. And we define the work done on a gas to be negative P delta V, where delta V is the change in volume of the gas, assuming we're dealing with a constant pressure. All right, so I hope that was helpful and not too crazy confusing with negative signs.